Hi, everyone. My name is Thomas. I work on Chainlink, which is a decentralized Oracle network. I also write the documentation, and I help node operators get started running nodes, and I write Chainlink contracts, which is what we're going to be doing here today. So, as a brief overview, we're going to talk about what Chainlink is. We're going to present a sample problem, and we're actually going to deploy and use a Chainlink contract. Then we'll end with questions. So in order to understand Chainlink, we need to first understand that smart contracts cannot access external data on their own. And this is a big limiting factor for smart contract adoption because it means essentially right now smart contracts can only do token transfers. So one of the key problems that we're solving with Chainlink is getting external data to smart contracts. So there are like thousands of APIs right now that power web applications, and what we do is we enable smart contract developers to get the data from those APIs to their smart contracts, so that now you can develop decentralized applications powered by the same reliable APIs that currently power existing web applications. Then there's also the fact that not everyone wants to be paid in a cryptocurrency just yet. So we make it possible to pay out through traditional payments providers upon the execution of a smart contract. And then along the same lines, we make it easy to connect to other blockchains so that you can execute a smart contract based on the event of another blockchain, or you can send an output to another blockchain based on the execution of a smart contract. So we enable this connectivity through what we call external adapters. And external adapters can be written in any programming language that you want. They simply need to respond to specific requests from a Chainlink node and respond with a data payload in a way that the Chainlink node can consume. So because of that, it's really easy to get started on extending the capabilities of Chainlink without having to know anything about Ethereum or even Solidity. So to get a bigger picture, Chainlink is a decentralized Oracle network where you can select as many Oracle nodes or Chainlink nodes, as we call them, as you like. And then as such, you can select as many data sources as you like to trigger the execution of your smart contract. And then upon that smart contract's execution, you can also use Chainlink to pay out in a traditional fiat currency through whatever payment provider you prefer. So we're going to use a use case here today that retrieves the current price of Ethereum and feeds that into a smart contract. So when a smart contract knows the market price of some asset, it can do things a little bit more interesting, like basing a payment off of the value of that asset instead of just blindly doing a token transfer for some amount. So for example, let's say that Alice has a website and she's contracted Bob to do some SEO work for her. If Bob can get Alice's website to the first page of most major search engines, then she'll pay him $50 worth of Ethereum. In order for this contract to work, we need to retrieve the ranking of Alice's site across multiple sources, and then depending on that result, we need to then look up the current price of Ethereum. Once that price is fed back into the smart contract, then we can pay out Bob. So they'll make a smart contract that essentially says, check the current ranking of Alice's site, and if that value is less than, let's just say 10 for an example, then retrieve the current market price of Ethereum. When that market price of Ethereum is fed back into the contract, pay Bob at such and such address $50 worth of Ethereum, and then we can send the remaining over to Alice. So Alice will fund the smart contract with some Ethereum so that all parties can know how much Ethereum is present on the contract, and then a Chainlink request can be made, which notifies the Chainlink network that this request came in, so Chainlink can retrieve the ranking of Alice's site across multiple data sources. An aggregate answer can be sent back to their smart contract, where the logic of that smart contract can determine if that was valid for their agreement or not. And if so, then the current price of Ethereum can then be retrieved through another Chainlink request, Again, that answer can be aggregated and sent back to their smart contract, where we can fulfill the payment to Bob and send the remaining over to Alice. So this smart contract enables chain-linked connectivity by being a chain-linked contract, which means that it inherits the chain-linked contract that we have developed that gives it the ability to notify the chain-linked network that a request came in. And then it also fulfills the methods necessary to receive the answer, so we'll commonly refer to that as a consuming contract. We're going to be working on using a chain-linked contract here today. So there are several ways to create a chain-linked contract. You can use a web-based IDE like Remix or Superblocks, or you can use a local development environment like Zeppelin OS or Truffle. A web-based IDE is really great for getting started without a lot of setup because you don't need a development computer to write and deploy and use smart contracts. And setting up a local development environment is really great if you have like a more complex project and you want to integrate some testing into your Solidity project. So the focus of today's talk, we're just going to be using Remix to deploy a smart contract, and then you can use what we learned here today to whatever development environment you're most comfortable with. So before we get started, I'm going to display several links and things that you would need to copy on the screen. Instead of having to worry about that on each individual slide, this is the only link that you really need to copy or take a picture of, whatever you need to do. I have on this page, it's broken down per slide. Anything that you would need to copy will be on the slide. There we go. I'll take a minute so y'all can get pictures. Mostly good? All right, so we're going to use the Ropsten test network for this example because it behaves a lot like mainnet, and we can take advantage of ENS. So the first thing that you're going to want to do is install Metamask if you don't already have it, and switch to the Ropsten test network. Metamask is a wallet that acts as an extension in your browser. It just makes it really easy to change to the different test networks and get started using contracts right away. Then once you have Metamask configured, you're going to want to obtain some Ropsten Ethereum, which we have multiple Ropsten faucets available. Again, these links are on that workshop page. And then once you have Ropsten Ethereum, you need to obtain some Ropsten Link, which we have a faucet set up for that. It's really straightforward. You just paste in your address, you solve a captcha, you click the button, and it'll send you 100 test Ropsten Link. On the test networks, we use one link per one request just to make it easy and straightforward. So yeah, once you have the link token, you need to add it in MetaMask. So to do that, you should be using that workshop link because you can just easily copy the address to our link token and you add a custom token into MetaMask. Also, since we use ENS, you can click send and type in the ENS address on the screen and it should automatically resolve to the link token address. But again, you should be using that workshop page. Then in your browser, you're going to navigate to Remix, which is a web-based development environment for Solidity. If you use the link on our workshop page, it should automatically select the compiler version for you. Otherwise, you'll need to manually select compiler version 0.4.24 because that's the version that we've locked the pragma line in our chain-linked contract to. Then once Remix is opened up, you want to grab the example contract that we have in our Chainlink repo. Remix opens up with an example contract.ballot.sol. You can overwrite the code in that and it'll still work fine, or you can just create a new contract in Remix's interface. The end result is the same. You just want to make sure that you get all that code into Remix. Then once you have the code in there, you want to click on compile, and you should see the green contract names on the sidebar in Remix. If not, then double check your compiler version, double check that you copy and pasted everything in there correctly, but otherwise it should compile fine, and it should say, like, it should have all the green contract names in the sidebar in Remix. So then once the contract is compiled, you'll go to the Run tab in Remix, and you want to check and make sure that the environment is set to injected Web 3, because I think if it's like the first time that you open up Remix, it may default to the JavaScript VM. But if you use injected Web 3, then that's ensuring that you're going to use Metamask. And then essentially all that you have to do is just click on Deploy, because a RopstenConsumer should already be selected at the dropdown. Once you click on Deploy, you'll just have to approve that contract deployment in Metamask. And then you'll have to wait a little while for that contract to deploy. But once it does deploy, Remix's interface will update to display the contract name. And then there's a little page icon button that you can use to copy. And I was playing around with it this morning, and it doesn't seem that that button is copying it correctly. So you may actually have to open up that transaction in like Etherscan to obtain that contract's deployed address, just so that we're aware for this workshop. No, let me go back one. And then once that contract's deployed, you're going to want to send at least one link token to that contract address, because the requesting contract has to be funded with, at least on Ropsten, one link to make a request. And then while you're waiting on that token transfer to complete, you can grab the input parameter for our request Ethereum price method. Basically what we're doing here is we're using a job ID, and then we're specifying a currency for the price of Ethereum to be converted to. And we're going to get into what that job ID means here in a little bit, but essentially once that token transfer is complete, you should be able to click the request Ethereum price method in Remix, and if you don't get this error message, then you made a Chainlink request. This is the most common error that I see when using Remix, and it essentially means that that contract has not been funded with enough link to make the request. So if you do ever see this error message, check and make sure that that token transfer was successful, so that that requesting contract is funded with link. So now, assuming that the request did go through, this is what just happened. Your requesting contract made a Chainlink request to the Oracle contract residing on Ropsten, and the Chainlink network is monitoring that Oracle contract for that job ID that you specified, so that when a request comes in with that job ID, it knows to perform some work. In our case, that work is to retrieve the current price of Ethereum, which it will do, and then return that value back to the Oracle contract, which then returns the answer back to your Chainlink contract. So by now, as long as the Ropsten network is working correctly, Chainlink network should have fulfilled that request, and you should be able to see the updated price of Ethereum by clicking on the current price button while interacting with your contract. So now that your contract knows how much the price of Ethereum is, it can do interesting things like deposits and transfers based on that value, similar to the example that we talked about with Alice and Bob. So now let's actually do this in a virtual machine. That's not going to work. Oh, that's not going to work. Here. All right. Yeah, I just need a... Where's my... Oh, I need to see the screen. There we go. So this is the, oh, this is going to be awkward, but this is the documentation page. And this looks like, this is unreadable. This is the interface for Remix. And I've essentially cheated a little bit here because I don't want to type in my password live because I'm just going to mess that up. So I've already got Metamask installed and configured and set up for the Ropsten test network. Essentially, all that we need to do now is grab the RopstenConsumer contract and paste it into Remix. So this is where we compile it, and that is completely unreadable, but we can see all the green contracts here, so we know that it compiled successfully. This kind of looks right from what I can read, and we just hit deploy. And then we'll see some nuances with Metamask that are affecting us today. So I just have to hit edit and select a price and save so that it'll actually deploy. So right now what's happening is I signed a transaction to deploy our example chain-linked contract, and I would really have liked to be able to show you the code within here, but that's completely unreadable right there. And then another problem is once this interface updates, I'm not going to be able to click on that little page icon. So I'm just going to middle click on this link here for the deployment, and we're just going to watch this transaction confirm. And then this is how I'll get the actual deployed contract address. Yeah. What happens if I do what? Oh yeah, just to enlarge it. Yeah, thanks. Awesome. So here we got the deployed contract address, and it's like it's bigger, but it's still not really readable. So essentially here now we just want to send one link to it. There's no way that I can enlarge this, but I think that it's pretty easy to figure out what I'm doing. Another nuance here is you have to click on the transaction fee for Metamask to update the gas amount for a token transfer. I'm just confirming that transaction. And then while we're waiting on that transaction to confirm, let's see if I can, it's a little bit better. Anyway, while I'm waiting on that transaction to confirm, I'll go back over to the workshop page where I can just copy this input parameter. And I really can't, I think it's this one. We'll see. Let's make sure that token transfer's gone through. It hasn't gone through yet. So I can show you this error message. The contract's not funded yet. But then once this token transfer completes, while we're waiting on that to confirm, then I should be able to make the request. I'm usually really unlucky with Ropsten sometimes. When I really need it to confirm fast, there it goes. So now we can see now that the contract's funded, we can make the request immediately. Again, I'm just updating that transaction fee so that it actually goes through. Now what's happening is that request is being sent over to the Ropsten Oracle contract. And we have a Oracle node that we can use during this hackathon to monitor that Oracle contract, and it'll fulfill requests. So I still can't really make it too big here. Yeah, because I'm going to lose that. Right now, I'm waiting on the Oracle contracts transaction to confirm on the blockchain. So even though that request just confirmed, it doesn't mean that we got a response right away because the Oracle has to see that response or see that request, reach out to the endpoint and make a new transaction. And that's what we're waiting on now to confirm. But we can see here that we're just specifying the URL within the Solidity request method. And then now, assuming everything's working right, it hasn't updated yet, but at least that shows that I haven't hard-coded a number in there. And this is the actual request method that we called. So with a chain link contract, you can specify a URL, and then you can also specify a path, which is the path of the JSON response that you want the chain link node to parse to return back to your smart contract. So in our case, we just want the currency. And still waiting on that confirmation. So yeah, in our case, we're specifying the currency, and that's the actual path that we want the Chainlink node to parse. And then we're actually going to multiply that value by 100, since Solidity doesn't handle decimal values. And again, I'm getting really unlucky with Ropsten confirmation times. But yeah, essentially, once the Chainlink node's fulfillment does come back on chain, we'll see a value that's been multiplied by 100 here. Should be any second now. No, we can give it a few more minutes. Let's open up to questions now while we're waiting on that confirmation. Yes. He asked who's paying the gas for the oracles, and it's the Oracle node operator that pays the gas, and they take the payment in link. Still no. Another question? No. All right, I'm going to call that I'm just really unlucky with this confirmation. Yeah. Oh, got a question. So the question is, how do you trust the Oracle data? So our method of doing that is the more Oracle nodes that you select, the greater assurance that you have that the data has been retrieved correctly, because you have multiple independent node operators that if they've even if they've only reached out to a single endpoint, you get a better assurance that the majority of them are not lying. If you have multiple data sources, you get a better assurance that the data is correct because you have multiple node operators, each gathering answers from multiple sources. Yeah, I'm going to call that. Do we have? Yeah. So he asked, I hard-coded the URLs into the contract, and what happens if they change? Yeah, in this example, you would have to redeploy, but the more modular approach would be to use that URL as like an input parameter, and then you could also specify the path as an input parameter as well, since usually when you change a URL, you may want a different path to be returned. Is that, like, basically everything there could be an input parameter, or that could be hard-coded into the job that we're specifying. Yeah, we're not going to get a response. Oh, no, we got it. Just took a while. Yeah, thank you, Ropsten. So, any other questions? Yes. So the question is, how do you deal with multiple nodes worldwide trying to get something like price data? So in the bigger picture, as a requester, you're going to select these nodes that they are saying that they are making this data available. So you will essentially propose a service agreement using our own terminology. They will accept that service agreement or they will reject it based on additional parameters that you specify. So once they've agreed to it, then they have actually made a signed transaction that they will fulfill those requests. And if they don't fulfill the request, then they get penalized. Like they can lose a deposit, they can get their reputation harmed, things like that. The comment is each node is asking for a price at a different, oh, so you mean like they're retrieving a price and because of volatility, the price changes. So yeah, when the nodes answer back, like this is just a single node, but when multiple nodes answer back, you as a requester also select a aggregation function for all those answers to be ran through. So you can take an average, you can take the first responder, anything you want. Any other questions? No? All right, if not, then that's the end of the talk. We're doing a hackathon, so we are here to help you if you're making a chain-linked contract for the hackathon. We'll be at the booth. This example is like a really good place to get started. If you have some custom like endpoint that you want, just let us know and we'll see if we can get it set up in time for you to be able to demo for your project. So that's all that I got. Thank you very much.